That skill presents reviewing numbers. If you think about the number line, we have 0 right in the middle and all the positives to the right of 0. It extends on either side of 0 all the way up to infinity. There is no end to the number line. So we have 1, we have 2, we have 3, we have 4, and so on and so forth. They are the positive integers to the right of 0. And we have the negative integers to the left of 0. Negative 1, negative 2, negative 3, negative 4, and so on. Now the set of integers, when we talk about integers, it's the set of all these numbers. So you have, it starts all the way from negative infinity. So I put the dots to indicate it goes on and on, even beyond negative 5. Negative 5, negative 4, negative 3, negative 2, negative 1. 0 is also an integer. It's neither positive nor negative. And then you have the set of positive integers. You have 1, 2, 3, 4, 5, and so on. Dot, 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 all the way up to positive infinity. And this portion out here are called negative integers. This side of 0, like I said, is the set of positive integers. And 0, of course, is also an integer. And in between these integers, you have the decimals and the fractions. So, for example, 0.5 is right over here. That's 1/2, and so on. The set of whole numbers is essentially that portion of the integer set that are non-negative. That means you exclude the negative integers, and this portion is the set of whole numbers. So it starts from 0, 1, 2, 3, and so on. The set of natural numbers is essentially the set of positive integers. So you have 1, 2, 3, 4, and so on. So the only difference between natural numbers and whole numbers is that whole numbers include 0. Natural numbers start from 1. And then there's something called rational numbers. Let me write that name down. So we have rational numbers. And a number that isn't a rational number qualifies as an irrational number. Irrational. So we have rational and irrational numbers. A rational number is any number that can be written down in the form of A over B, where B is not equal to 0. The denominator of a fraction can never be 0. For example, you can think of any fraction as a rational number, like 1/2, 2/3, even negatives, because A can be negative. There's no restriction on that. So negative 3/4, they're all rational numbers. And if you think about the integers, other than 0, anything can be written down as that number over 1. So for example, if you want to rewrite this 3 as a fraction, so you could just write 3 is equal to 3 over 1. So 3 does qualify as a rational number because it can be written in that form A over B, where B, the denominator, is not equal to 0. This is 1. So all integers and these fractions that you could think of, they qualify as rational numbers. Now then the question is, what are irrational numbers? When do we say a number is irrational? An irrational number comes up when you have a non-terminating decimal. For example, a classic example of that is the constant pi that you use so often in geometry. It's a Greek alphabet, pi, and its value, numerical value is 3.14 blah blah blah. It carries on and the pattern never repeats. What I mean by the pattern not repeating is, If you think about the decimal number 0.333333, it goes on and on. So the 3 keeps repeating and you can rewrite that as 1/3. So this is a rational number. Even though it's a repeating decimal, it is a rational number because the pattern keeps repeating. But for decimal numbers in which the pattern doesn't repeat, they qualify as irrational numbers, and then there is another type of irrational numbers you can come up with. And they're the roots of integers that cannot be simplified to another integer. Consider square root of 5. We know square root of 4 is 2, but square root of 5 is not an integer. Square root of 10, that's not an integer. Square root of 9 is 3, square root of 16 is 4. So if you find out square root of 10, you will get, if you just, let's say, if you use your calculator to do this, square root of 10, you get a decimal number and you will see that the pattern doesn't repeat. So all these surds, square root of 8, and it doesn't only have to be a square root. For example, the cube root of 15. That isn't an integer as well. So that's also an irrational number. Next, we're going to talk about something really important, and they're called the factors or the multiples of a number. Factors are different, multiples are different. You need to know both. Multiples. I'm going to talk about multiples first actually, because the name implies it's something to do with multiplication. The multiples of a number are basically the numbers that you see on its multiplication table. So just to give you some examples, the multiples of 3 are 3, 6, 9, 12, 15, and so on. There's no end to the list of the multiples of a number. The multiples of 10 are 10, 20, 30, 40, 50, 60, and so on. On the other hand, the factors of a number are the numbers that can divide into that number. For example, let's talk about the factors of 12. Think about the numbers that can divide 12 without leaving a remainder. They would be 1, 2, 3, 4, not 5, because if you divide 12 with 5, you have 5 times 2 is 10, and then 2 is the remainder. So let's exclude 5 from that list, and then we have 6, and then 12. These are the factors of 12. Let's talk about the factors of, let's say, 15. We have 1, not 2, 3, 5, and 15. These are the only factors of 15. As you can see, the list of factors of a number is limited. It doesn't carry on and on, unlike the multiples of the number. And also, a number itself is a factor of itself as well as a multiple. So if you were to list down the multiples of 12, you would start from 12. So 12 is both a factor and a multiple of itself. And then, of course, 1 has to be a factor of every number. 1 will divide any number. And that leads us to something interesting called prime numbers. Prime numbers. Consider the number 11. What are the factors of 11? Factors of 11. You have 1. 1 is a factor of every number. And then no number between 1 and 11 all the way up to 10. And 11 is of course a factor of itself. Now if you look at the factors of 11, it's got only 2 factors, 1 and itself, 1 and 11. But if you look at 15, 12, the list is more than that. Factors of 12 are 1, 12, and a few more. Numbers like 11, and there's a whole bunch of other numbers like, think about 5, 7, 11, 13, 17. Such numbers, that have got only two factors, 1 and itself, are called prime numbers. On the other hand, numbers like 15, numbers like 12 that are not prime, having more than two factors, are called composite numbers. Composite numbers. 15 also qualifies as a composite number. So you have primes, you have composites. Now if you come to think about even numbers, because even numbers by default will have a factor of 2 no matter what. So you tend to think that all even numbers are composite. But you need to be careful because there's one even number that's prime, and that number is 2. 2 is the only even prime number. And the reason is, I had said that prime numbers have got only two factors, and they have to be 1 and the number itself. Composite numbers have a minimum of 3 factors. So composite numbers would have a minimum of 3 factors. For example, 9. 9 will have 1, 3 and 9 as its factors. So 9 qualifies as a composite number, not a prime number. But if you think about 2, what are the factors of 2? The factors of 2 are 1 and 2. So 1 and itself. So that fits into this definition of prime numbers. So we say 2 is the only even number that's prime. And then you have that number 1. That's neither prime nor composite. Is 1 a composite number? No. Why not? Because it doesn't have 3 factors. Is 1 a prime number? No. Because the factors of 1, well, 1 has got only 1 factor. Prime numbers will have 2 factors. So it's neither prime nor composite. That's the only number. All the other numbers, the other integers, can be classified either as prime or as composites.